Going to be talking about fused deposition modeling for continuous fiber reinforced polymers. All right, so the process description, it's just like FDM, but this has two print heads. Really, the first lays down a polymer like nylon or PLA. It's not really like a substrate or anything that gets removed later on. And then the other one lays down a continuous carbon fiber strand across the top of it. And there's some proprietary thermoplastic blend on this that adheres well to the nylon and the carbon fiber. So it's some kind of glue, I guess. Yeah. They don't tell you what it is, and there's really only one company that does this. So, um, anyways, some key process things affecting the part. Uh, the big one is the direction of the fiber. Like I said, since you're running just a continuous fiber in there, it makes the part really anisotropic. And also the fiber can't move in the Z direction, it's only in the X and Y. You can't weave it like your typical composite part. And the other stuff is, stuff that normally affects FDM, nozzle diameter, temperature, all that good stuff. But like I said, it's one company that does it. Their machine and process doesn't have a whole lot of knobs, so you're not going to be playing around with all that kind of stuff. They did say you can get down to about plus or minus 10 microns in the X and Y each layers. Anyways, some niche process capabilities. This is really driven more towards like a material selection type thing. So it's when you need a part that low volume or whatever for your typical ADM process, but it also has to be strong and lightweight. So motorsports, aerospace, bicycles. One of them they had on there was running blades, so Oscar Pistorius might like that if he wasn't in jail. So the company, the fibers that the company prints with are Kevlar, carbon fiber, and glass. Like I said before, the other one is nylon, and they have a proprietary blend of thermoplastic to bond them together. Some of the things they had out there was some people were talking about PLA for this and ABS. The company doesn't recommend it, but I'm not quite sure why you wouldn't be able to print with them in the nylon one other than you'd void your warranty. The company, like I said, started off with race car parts, and the guy who founded the company didn't particularly like didn't like the manufacturing process for it because it's fairly expensive to make these parts. You have a small number, so you need a specific die to do it. Lots of trimming, gluing, all sorts of labor that goes into it. And if you're trying to change the part, like if you're making a custom race car, you have to change that die, and it just gets really expensive. So this is a race car wing support, and you can see it up there in the upper right. And what they do is they print this nylon base, then they run a couple of rounds of carbon fiber around it, and then they finish off kind of sandwiching in between a couple other pieces of nylon. They did say that this is about half as strong as the best composites right now, so it's not quite up to par with something you would do by hand. But it's still pretty good. They said the modulus is close to that of an aluminum alloy. And you can kind of see a blown up view of the carbon fibers up there. And the actual cost of the part was about $25. And it's just a little tiny part. The actual machine itself it's only like 1 foot by a foot and a half, so relatively small, but you're not gonna be able to print an entire wing out of it yet. But the one vendor that they have out there right now is this Mark Forged. You can see the dimensions there of the actual part. They cost roughly $5,000. Some different vendors have different prices, but it's in that ballpark. And like I said, they only recommend buying their materials. Those are the prices they have listed for it, so a little pricey, but what's that? Yeah. Yeah. They had the first one listed in like dollars per. Anyways, just a little bit more about them. The guy is founded by this Greg Mark guy who he got a master's degree from MIT or something in aerospace, and like I said, he started off working with designing these race car wings and realized that the production process for them kind of sucked. So developed this company out of it to try to streamline that. And he got a bunch of other guys from PhDs from MIT working with him. There's like 25 patents or something out there. And I did find a second vendor. There's nothing. This is just a kind of a concept company. They're hoping to get a commercial printer out in between 2017 and 2019. And it's a 6-axis printer for carbon fibers. One of them's holding it and the other is moving around. If you go to the website, it looks kind of. I'm not quite sure how you do it without having the fiber moving all over the place, but I guess that's why it's just a startup company right now. But yeah, it looks pretty cool.